Now I'm very pleased to introduce Dr. Susan Amara. She is the Scientific Director of Intramural Research Program at the National Institute of Mental Health. She is a member of the National Academy of Sciences of the United States, a former Howard Hughes Medical Institute investigator when she was at Yale University. She was president of the Society for Neuroscience. She was also a distinguished professor and chair at the University of Pittsburgh School of Medicine. She works on structure, function, and cellular physiology of neurotransmitter transporters, genetics, and functional analysis of human trace amine receptors. She's done it all. So her theme is diversity in scientific careers. Dr. Amara.
Thank you. So I knew that by being the fourth speaker, everyone would have covered all the topics. So I've got some backup plans. You want to start? Great. I wanted to give a somewhat more personal view of diversity and also a little bit more kind of an optimistic view and really say what I view as, and what many of us view as why we need diversity. And I think it's a pretty compelling reason. Okay, great, thank you. So these are the three points I wanted to make during the course of my talk. I really wanted to emphasize the value of diversity to scientific research. I wanted to also emphasize the value of diverse scientific paths, which in some ways they go hand in hand. And then finally, because I really want to speak to trainees, although I'm not sure I see that many in the audience, I wanted to give a little bit of kind of practical advice to trainees. So these slides I'm going to skip through pretty fast, but it's very clear, and you've heard it from the other speakers, that there's declining diversity as we go along through academic careers. And it's pretty striking. There's the pointer. Okay, great. It's pretty striking how even once one gets a PhD, it shows the declining diversity that occurs, particularly for underrepresented groups, but also for women, and it ends up being a very male-dominated area, finally, and at higher levels. This slide illustrates how assistant professor appointments really lag behind the PhD recipients for minority groups and underrepresented groups. And what you have to think about in terms of looking at this differential is really the great loss that we experience in not having people continue on and move into science and contribute to science in diverse and interesting ways. And this simply shows, similarly for women, there's this loss that occurs over time by the time people get through their careers, and that loss is really distressing. So I wanted to illustrate a little bit about what diversity means and why it's important for science. The benefits of diversity. These hexagons illustrate, sorry, I'm having trouble here, illustrate what are viewed as underrepresented populations in the U.S. biomedical and clinical and behavioral and social sciences research. However, there are other kinds of diversity, and these all come together in ways that enrich science. So I think Delany expressed it well. The way you think, the language, your background, the experiences you've had all contribute to allowing individuals to really make important and unique, and this is important, unique contributions to science. And so, in many ways, we can think of diversity in a much broader context of how does it impact the way we do science. I've listed a few things here. Diversity is often a property of teams because it changes the way members justify their perspective. It tends to result in fewer preconceived notions and assumptions. It leads to more innovative decisions and encourages explanation and discussion. And really having people thinking about the same problem from different perspectives makes a huge difference in what gets accomplished. And I think there's also a tendency to be more creative because we're not doing groupthink. We don't all think alike. And finally, it allows for problem solving more effectively and better error detection rates because people, again, are thinking about their problems in different ways. So diverse organizations, and this can be departments at the laboratory level, at the institute level, at the institutional level, perform better in many ways. And I think it's a compelling, positive argument for why we need diversity in science. So this is what scientists look like. This is my lab a couple of years ago. I included it because I've got Delany and Jenny Garcia Olivares in the picture. But I've really enjoyed, and it's made a huge difference in terms of my own career, to have ideas from a broad range of backgrounds, and I've really appreciated this. I also want to point out that scientific careers aren't just training for academics. They're actually a broad range of scientific careers that we can undertake once we train in science. I actually, I didn't know about academics when I was training early on, and I decided in 8th grade I wanted to work for a drug company and develop drugs. Went on a field trip, saw them doing experiments. I thought it was really amazing. And I wanted to do this for a career. And so my view was that I would go into industry. So there's really a large, diverse group of areas that one can go into: biotech, pharma, government, and all of these are important for science. So the breadth of possibilities demands a diverse and diversely trained workforce. So there are major challenges to diversity. Unconscious and implicit bias that can be experienced, assumptions that are made even though they may not be applicable. There's a lack of inclusion that can happen. You can be invited to the party, so you can get a faculty position, and I think you expressed this well, Walter, but you might not be able to dance. And so that is also an aspect that we have to consider in terms of the challenges. There's often, and there is in science, an existing hierarchy and tradition. There's an organizational culture that sometimes takes place in different institutions. And many times, people who are diverse don't fit into those. And so a lot of those things really need to be revisited in terms of how to incorporate a diverse workforce into science. In addition, there's often unbalanced distribution of resources. It can be what you get for startup when you begin your lab. It can be your salary, and many of us have experienced that, where salaries vary widely in institutions. And then one of the ones I think is almost the most fixable one is not thinking about it. So I can tell you that I have people propose workshops and seminars for our institute, and what you often find is that you'll get a list of people, and there's just absolutely no diversity. There are often a very handful of women, no underrepresented groups, and when you ask, it's not that they didn't intend, they just didn't think about it. So it's this constant effort to try to increase awareness as far as increasing diversity. So I was going to give students, if there are any left, a little bit of advice, because in some ways you can't change the entire system all at once. And so having gone through my own career, there are a number of things that I think are important, and often they have more to do with the science than the politics around. Choose important questions, find the best approaches to address those questions. And this one is, I think, probably the most important. Work with people you admire and respect, and I'll mention my own experiences. The second is identify people who believe in your abilities. And so you can't fight all the battles. You need to set up your environment in a way that you can be successful. And I encourage all students to do that. And then one other thing is to recognize that there are so many different paths in science, and there are different ways to get to the end. And so the idea of, I can tell you, my own career had paths that were quite, you would never recommend a student to do them. And I made choices. I did too long a PhD thesis. I didn't do a postdoctoral fellowship. There were a number of things that were just, but they felt right for me. And they were in I think, probably the right choices. So I wanted to illustrate why I think it's important to work with people you admire and respect. I'll show you, this was my thesis advisor. And he actually, in a remarkable way, thought I could do anything. And I didn't think I could do anything. And he was really terrific at kind of encouraging. And I think choosing your environment to be a supportive one that allows you to thrive is going to allow you to stay in science longer. I had outside advisors. Wiley Vale, the late Wiley Vale from the Salk Institute, really has stopped and did things during my career that always helped and advised. Chuck Stevens was my first department chair. He actually introduced me to electrophysiology and biophysics, which has really helped in many of the problems that we've addressed. And then also wonderful groups of students and fellows who have been incredibly productive and helpful and have really taught me things. And I think in that case, it's sort of illustrating how having a diverse group with backgrounds that are different from yours can enrich and change the way you do your science. So I think I'm probably close to the end of what I wanted to talk about. I was going to talk about a little bit about choosing mentors, but I think I'll go to the end. There are different mentoring styles for trainees. I think the challenge is to learn from both. I actually had great mentors, and I had some not so great mentors. So it's one thing to learn. And I think I'll just end and acknowledge a couple of the people whose slides and things I've adapted. Hannah Valentine at the NIH is the Chief Officer for Workforce Diversity. She's done an amazing amount on that. Renee Ryan runs a program for gender equity in Australia, and she also has had a lot of influence. And then there are lots of places to seek out advice. So I think I'll end, and we can discuss more. Thank you.